we go. Alrighty, so just to start us off with this panel, I'm going to be introducing our panelists, of course. And first and foremost, I would like to introduce Dr. Jessie Burkett-Rees from the University of Monash, Monash University in Melbourne, Australia, where she is a senior lecturer, especially within the Centre for Ancient Cultures Centre at Monash University. She is a landscape archaeologist who specialises on riverine systems, working primarily around Europe, especially the Caucasus Mountain region within Georgia, working in Canada, within the Atlantic Ocean systems there, of course, and of course within Victoria, here in Australia as well. So she has also studied geomatic engineering alongside archaeology and has always been interested in how technology can be applied to help answer archaeological questions and to help communicate about the past with diverse groups, from traditional owners to local communities, students, and the interested public. She has used GIS, spatial analyses, and landscape modeling for many years, but has also worked with other non-invasive technologies, 3D scanning, photogrammetry, and digital artifact modeling. Fieldwork and material analyses remain essential in her work, but especially in last year, under various lockdowns, digital technologies have proven their relevance, especially for what she has been doing so far. So Jessie, welcome you. We also like to introduce to the panel as well, Hans-Dieter Beider. Hans is the owner of Archaeology Solutions in Auckland, New Zealand, and is an honorary research fellow of the University of Auckland. He graduated with a PhD in prehistory and early medieval studies from the University of Marburg in Germany. He's an archaeologist whose research interests have spanned from studying prehistory and early medieval studies within Europe to archaic Maori and early European sites within New Zealand. His field experience of over 25 years has seen him work on sites dating from the Neolithic to the 17th century in Central Europe, Germany, and the Near East within Turkey, Syria, and Israel. He has also worked extensively in New Zealand as of late, since the 1990s, working on archaic Maori and early European archaeological sites, utilizing a wide range of technologies, including GIS and geophysical surveying as part of his work. Next up on our panel, of course, is Kelsey Lowe, who is a research fellow and archaeological heritage consultant at the University of Queensland Culture and Heritage Unit within Brisbane, Australia. Her research focuses on developing techniques that assist in understandings of past human behaviour, cultural landscapes, and the spread of modern humans through archaeological, geophysical, and geoarchaeological applications. She has used a lot of interdisciplinary methods with particular emphasis in archaeological geophysics, remote sensing, GIS, and geoarchaeology in archaeological research and cultural heritage management. She has worked extensively on sites worldwide within the US, Europe, Southeast Asia, and Australia. Recently, she is exploring how sediment magnetic susceptibility and other techniques like soil chemistry and geochronology can be used to understand the nature and persistence of Pleistocene human occupation within Australia. Last but not least, we have Dr. Simon Bickler, is an archaeological consultant working for Bickler Consultants based in Auckland, New Zealand, where he received his MPhil from the University of Auckland, his PhD from the University of Virginia in the US as well. Simon has directed numerous projects around New Zealand and continues to publish on a range of topics, including applying computer simulation, machine learning, and other data analytical approaches to archaeological problems. Guys, welcome to the panel. And for those who have just joined us as well, Damien Evans could not be with us today, unfortunately. He sends us his deepest apologies. He is in Laos at the moment and is in an area where, unfortunately, he could not join us on a video call, unfortunately being in COVID quarantine, unfortunately. Of course, due to the whole worldwide situation, it is what it is. But again, he sends his deepest apologies and will hopefully be able to talk at another CAA Australasia event later this year. So welcome one and all. And of course, with this panel starting, please keep yourselves muted and your video off if you're not a panel member, of course. And without further ado, we're right on time here and there. And we'll start off with the first question, and a question in particular, which may be quite interesting and for all you panel members. Do you guys all remember when you first used a laptop in the field? Kelsey, maybe you could start us off.
Yeah, I remember the very first laptop we used, but I remember, I guess I go and date myself back to the first time I was even recording geophysics, as I would just hand record them and put them down to an Excel. So I go back even probably a bit further before the laptop. But I do remember when I got to use my first laptop in the field, it was pretty clunky, and battery life wouldn't last very long. So yeah.
Oh my goodness. And especially, yeah, because of the clunkiness, and at the time probably would have been one of those situations going, how the heck am I going to be using this? This is so cool, but how to use it in the field specifically.
And then probably putting an umbrella underneath because the screen wasn't adjusted for the sunlight, and yeah.
Hans, what about you? It's been a while, I guess.
Yeah, it's must go back to the mid-80s, and it's Amstrad, no batteries, no hard drive, 2 of the 5-inch floppy drives, and a cut-down version of D-Base. And it was driven with a car battery and a solar panel. And it was in Turkey, which, was challenging to say the least. But it saved me from transporting probably half a ton of ceramic from the site to where I have the laptop, and I could do the work, the databasing, straight into the machine.
Oh my word. Jessie, what about you?
Mine would have actually been early 2000s. That's when I sort of started doing my fieldwork. So laptops were around, but I think the points about battery life certainly something that resonates with me, where you'd have to have something that you really couldn't use for a very long period of time. So you had to be quite organized and focused in how you got the data down and imported it. But also, like Hans said, it ended up saving time in other areas, even with the quite vintage technology that I was using.
Yeah, for sure. So much data that could be saved physically, but more data virtually, pretty much. Simon, what about your experience of using a laptop in the field for the first time?
Yeah, well, I think I go back to a similar period of Hans, and I took one out to the village in Woodlark Island where I did my doctoral research, and I had to use a solar power to generate it, which gave me usage of it about every 2 weeks. I could sort of catch up and do a bunch of typing, and that was about all I could manage.
My goodness, just work with that laptop, Simon, or?
Oh well, the games weren't the best, but yeah, I think I mentioned that that would kill the batteries pretty quickly.
There you go.
But it was quite fun in the village because they.
Oh dear. And here we are, ladies and gentlemen, technology at its finest. Hopefully Simon will be able to join us soon enough. But yeah, it is what it is. We'll see how things will work out. Hopefully he'll jump on with us. While we are waiting for Simon as well, because I mean, in terms of asking this question about laptops, because since you guys were first using, Simon, are you back with us?
Yeah, can you hear me?
Yes, I can hear you now. You just froze a little bit.
Oh, okay.
Yeah, no, it's all well and good. Just in terms of talking about how you guys were first using technological applications for the first time in the field, what have you learned about the new technologies that they've used since then when you first used those laptops, and how have they applied to your archaeological projects since then, like in terms of not just from the laptop that you have, but since then pretty much, and how that adapted to the archaeological projects that you have used? Hans, maybe you could like to start us off.
Yeah, I think there are 2 things, and by far the most important things is GPS, handheld GPS, that completely revolutionized how we go out in the field. I'm coming from a background, was in the German Army artillery, and so we have been using theodolites and military grade sort of maps to know where we are and all the rest of it. And I still remember in Turkey, I was having a night session with a very expensive geodetic theodolite to follow the plan of the Pleiades, Matariki, to get a orientation and a location done. And today, you take your cell phone out and you push a button, and in a second, you know where you are. I mean, that's must have been the most revolutionizing sort of technology for the field work. And then obviously right behind it, digital cameras. Because I still remember how I rolled up black and white films into handmade little roll, so you could actually afford the amount of film that you needed on the sides. And that's with digital cameras, it's all gone. I mean, it doesn't matter if you do 36 pictures of a site or 360 or 3,600 because it's digital.
Indeed. Yeah, of course. Especially with how GPS we take for granted, and we have also for our attendees, if you have any comments here and there, if you'd like to chuck them in the chat, by all means, you can do so. We have one from Natasha saying like, yeah, GPS is something we all take for granted as of now, which is something that, well, 10, 15 years ago, it's something like we had to really get a specialist to bring in this type of tech on a site and just to be able to pinpoint exactly where we are now. And it's just incredible. Of course, nowadays, if, most of the technology that we have, we can use it most parts of the world, but not everywhere in particular, especially, and we have to keep that in mind. Jesse, with your work in particular, working in Europe, how has the technology been developed for your projects, not just in Europe, but also Canada, especially maybe in very remote areas? Has technology changed to such a degree that has really assisted you, or do you still find there's issues with the development of these techs within your projects?
I guess for me, it always depends on which area you're working in. So if you're working in Eastern Canada, for instance, then everything's extremely accessible. So I could get base LiDAR maps from the government for free, these sorts of things. Whereas if you go and work in the Caucasus, you're not going to find that information quite as easily. So I see Hans is recognizing what I'm saying. So it can also, I mean, you can think about where you're working in relation to current political borders as well, where different sorts of tech might be acceptable or not acceptable. So I'm thinking in that respect of, say, using GPS or how accurate that GPS might be in particular regions, because of course we think of it as always being highly accurate, but it's controlled. So if they want to make it less accurate, it can be done. And the same goes for, say, use of drone technology, which is something that a lot of us use now, I think, which has meant that we can easily take our own aerial imagery of our sites or the landscapes that we're working in. But of course, that technology isn't always acceptable. So for colleagues in Egypt, for instance, they're not able to use that. Whereas it's something that in Victoria, it's relatively simple to use. In Canada, relatively simple. In the Caucasus even, it's acceptable.
Oh yes, I can vouch for that. A few years ago when Egypt banned drone usage, it was just like, why? But of course, as archaeologists and cultural heritage practitioners as well, we have to keep in mind of all these different rules and regulations with all the countries that we do our work in. We have to respect those particular decisions, but it does get a bit tricky when these technologies that we do use, especially drone usage, where it does provide such great data for landscape viewing of the site from a bird's eye view. But unfortunately, due to some countries' regulations, we just cannot do that everywhere in particular. Hopefully that changes, but of course, we still have to keep this in mind in regards to country regulations and all this. And that's something that archaeologists have to keep in mind of, and not to mention political reasons behind that included. Simon, with your work as a consultant archaeologist in New Zealand, how has technology for archaeologists developed in your time so far? And what has been maybe the biggest surprise for you with how technology has really assisted with your consultant work?
Well, I think I agree with Hans and Jesse on, it has been the GPS. I mean, my first one had a plus or minus 120 meters, and I thought that was amazing. But I think that the other one is sort of, robotic total survey has also changed things quite radically, and, so we know Hans is a massive fan of that. And because it sort of freed us up to, instead of having to be very rigorous on grids and when you're under the pressure from, earthwork heights and things like that, being able to just, and high resolution totals, high resolution GPS total station, RTK, all that sort of stuff, it's freed us up to work across, quite large areas with, really amazing accuracy. Whereas, before that, laying out grids, setting yourself up, very difficult. And so there's enormous freedom to create the environment for excavation that suits you, and know that you can, walk onto a site and walk off it with a high resolution map. I think that's probably the most useful of the things, that I would add to it.
Rightio, there you go. And Kelsey as well for you, because you work in a very bit of a niche part with geophysics as well. I mean, Simon has experience there, but especially
and Hans
is included, yes. But just to go to Kelsey, because you've come from the US, where very different ways of using geophysics over there, and then coming to Australia. Was there, I guess, any surprises for you with how geophysics technology was used in Australia compared to the US for you?
Yeah, I was actually surprised about how little it was used. And I think there's several reasons probably for it, and I won't go into detail, but I think when I was really fortunate as an undergrad in the United States to get trained in geophysics. It was either underwater archaeology or geophysics, and being in Minnesota, underwater wasn't really going to cut it. So then I thought I had this person named Renita Dalen, who was kind of the guru, first generation, that just offered the chance to do geophysics. And I took the class and I fell in love, and I loved the geoarchaeology and landscape. So it was really, I was at a time at the best time for me to be at its heyday, when it was starting to take off more in the Americas. So coming to Australia, even though I was surprised that it wasn't so prevalent, I could use what I did learn from the United States to take it and incorporate what my knowledge was, and see how it can move forward. And I think, it is still probably lagging in some ways when you think about the UK and North America, but there are some more changes over, I guess, in the last probably 10 years. And as a person that's being employed in it solely on a side job, it have seen a significant change. And I think the thing is with all of this, when we are talking about technology and the work that we're doing, is the efficiency for us to be able to do the work much more accurately, to map a landscape, 20 years ago compared to what we can do now, of everybody having handhelds or, a small like Trimble handheld in your pocket. It's just so incredible, and we can start to change the way we do archaeology in that realm with the technology. So I think when I first started out to doing those pedestrian surveys to what we can do now, it's been really, really cool to be a part of that, and to continue to learn. I think all of us too are probably pretty excited what we're going to learn in the next 5 to 10 years of technology, and how it will even shift a bit more archaeology.
If I can sort of jump in, if you don't mind,
Yes.
I was lucky enough that I had some mates during the studies that were going down the road of geophysics, because it most definitely wasn't taught when I was going through university. So I sort of kept up in contact with them, being in New Zealand, and so sort of see what's going on. And I think the computer technology that you can actually save the data and display the data was really the breakthrough for geophysics in archaeology. Without having computers there, I still remember my first geomag survey was writing numbers on a piece of paper in a grid, which is like painful, very, very painful. But I also think that with geophysics, we're probably sort of, despite the work that has been done overseas, and New Zealand and Australia are pretty much the same, that it's very little used compared to Europe. the multi-directional, multi-channel GPRs that are sort of coming on the floor at the moment, that use up a huge amount of computer power, they might actually be a really next big step. I have only used a couple of times one here, and it's and when if you're in a car park, fine, because the machine is about 100 kg. But the moment you drag it out into a cow patch, you're stuffed. It just doesn't work. But I can see that the development of the computer is going better. And you do a little area 50 by 50 and you have a gig of data. It's like getting a terabyte of data. It's sort of like a massive amounts, and your average computer just sort of waves you goodbye if you're trying to do something with the data. But there is the next step. You can already see it coming.
There you go. And we've already talked about a different range of technologies amongst us already. And of course, we have such a wide range of choices and options. But what informs your decisions in terms of what suitable technologies are suitable for the projects that you guys are using as opposed to others? Simon, or maybe I could start with you. What technologies sort of like when you are figuring out the proposals for a new project, what sort of technology, how do you sort of determine which technology is useful compared to others for your projects?
It's usually the scale. I mean, that would probably be the number one thing: how big an area you're dealing with, what you're doing, how much you're going to gear up, and then the complexity, the archaeology that you're expecting to find. So that would be the main trigger on that. Beyond that, of course, it's availability and cost. But the bigger the area, the more complex the archaeology you're going to find. You're going to have to record is going to be the major factor in determining how much, which technologies you use.
There you go. Jessie, what about yourself?
Again, I think for me, it probably depends on where the site is as much as the questions that I want to answer about that area too. So I think we do have this amazing array of technology available to us and all these experts who can work with it. But ultimately, we're still interested in archaeological questions. And so we want to try to tailor the tech that we're using to the research question as much as anything, or the project objectives. And so for me, I think it's sort of starting with what's the purpose of this project and then integrating the tech, rather than sort of starting with the tech, as fun as it is, and making questions on the basis of that.
Indeed. Hans, for yourself, because working in New Zealand archaeology and coming from Europe, and as of course talking about how geophysics has sort of been little utilized in around here in this part of the world. For you, with the different sorts of texts that you have used, how have you been informed to sort of like, again, maybe jumping on to what Jessie has talked about, sometimes when people probably have asked you for advice saying, oh, what type of text should I use? And sometimes some people could fall into the trap of when they're creating new archaeological projects that they have to feel that they need to use these new technologies to stay relevant. Is it a difficult conversation sometimes maybe when people fall into that trap of like needing to use these new technologies to stay relevant and moving away from what the real purpose of an excavation or survey entails, by asking like, well, is this helping me to answer the research question?
You see, the problem is in a way that both that I suspect, so Simon, is the same. The difference that you have in contracting archaeology is that you don't have the luxury of a research question often, or let's say you really have to have a large scale landscape overview where you are, and then you get thrown into a site through the development, and then from the landscape and from the history of the landscape, you then sort of like, okay, what's the focus that I can actually use here? But you cannot decide where you go, because it's like the motorway gets built or the motorway gets built. Sort of like you don't just, or could you just move it over 100 meters so I get that research project?
Yeah.
Sort of, that's not working.
Mm.
But I think for me, it's you always start with the GIS, and we haven't talked about GIS. And I think that's the other, I seen it's come through the chat, Geographic Information System. I still remember the first time I used what was it?
ArcGIS.
ArcGIS, and it was line coded, and you had to wait for half an hour on the computer to see if it worked or not. And if you started to wait for 45 minutes, you assumed that the job went down and you did some comma in the wrong place.
No.
But that has essentially well moved on from there. And I'm using QGIS, which is free, essentially before I even start anything. Sort of like when I get contacted about a job, the first thing that I do is open up the GIS, get all the free data that the government has online, and see where I am, what the landscape is doing, what archaeological recorded sites are around. And all this stuff is essentially at your fingertips. And then I have the advantage that my truck, everything is in my truck. So I have the drone in the truck, I have a flux gate radiometer in the truck, mattock, shovel, whatever you need. And so you essentially just open up the truck, look at the site, and take out whatever you need.
There you go. I have an interesting comment from Natasha Phillips, and she talks about how the weight and portability of geophysical and scanning equipment is such a challenge. You talk about all this equipment in your truck, Hans, but it also can be quite annoying at times. Maybe it's like, oh goodness, this is a site where I need to have everything on board. I need to take everything out of a truck.
It's becoming challenging when you have to use the plane.
Yeah.
As long as I have a pickup truck with me, it's fine.
There you go.
Yeah.
Kelsey, with your work, you've sort of dabbled between academia and also consultant archaeology in your career so far as well. Of course, geophysics is your main bread and butter, but also GIS has also been something that you've delved in quite a bit. What has sort of been, I guess, the challenges and the developments of GIS that you have seen in the last 25 or so years? I mean, Hans has talked about we started with line coding. And so many people are going, wait, what is that? But nowadays it's something that that people don't realize because the interface has changed so much that it is user friendly. What are some of the changes that maybe you've seen in the last decade where maybe initially it was hard to sort of get your head around it, but now the user friendly aspects of GIS is becoming more accessible to people today?
Well, I guess, because I got into GIS through just mapping, and I even started off with using the old transit before total stations were a thing. And I think that I'm actually really glad I learned that, because there are places I work in the world where you're not going to have access to a total station. You might have to pick up a transit. So I think when you think about that, it is pretty crazy, because I remember learning my first GIS course too in ArcGIS and thought, wow, it's hard to get your head around the first time. But then I was using programs like Surfer what was the other one? ERDAS, Imagine. So all these different spatial softwares where now, you use ArcPro and it's so more intuitive than ArcGIS. And I guess the thing is I'm really glad to see that spatial data is becoming part of the norm, and it's more readily available, and getting people to do it in both consulting and research is making it a very efficient way for us to essentially map these sites. And so I don't know if I'm answering the question correctly, but I was just like, because everybody else kind of have filled in, and I agree with them that everything you do is a project by project change, and GIS is, I wonder what it will be like in the future, because spatial data is now made to everybody. Like even Google Map, you're using some type of spatial, but do you lose the principles behind how spatial data is collected, the points, lines, and polygons, the attributes, the database, which I think is another, I guess if I wanted to add in, is the other cool aspect of GIS, is that it's just more than a spatial, it can do so much. And I think the scene where it first started, and remember when we all used ArcMap and it was like 3.1 and you're like, oh, that's an ugly map, to what you can come up with now. It's just an art scene in the 3D. It's really, it's amazing. Yeah.
It's all
I actually,
sorry.
I was just saying, I actually had to write my own one for my PhD research because none of the maps existed for my island, particularly except old World War II maps. And I think Moira, who's online, I think she may have digitized it for me because the department, she actually went around and gave me my base map, but all the stuff to connect it up with all my results, I had to actually code in Pascal on my PC.
Wow.
But the other big thing that, everybody's touched upon though, but I think is really the big transformative element is the data that's available, and the scale of that data is breathtaking. So we started a voyaging simulation back in the 90s. I was looking at all the climate data and everything like that. All of that, including all the code to run it, everything like that, fit on less than a 1.44 megabyte floppy disk. And in the sort of revised thing that I've been working on now with my colleague Ben Davies, we download 85 gigabytes of worldwide weather data, and there's terabytes generated every day that we have access to. And as things like LiDAR come on, the scale of this information just keeps exploding, and being able to access it geospatially is just amazing.
There you go. I just wanted to probably pivot to another realm here as well, and especially with the work that all of you guys are doing, where you're working with so many different local communities, whether it be Indigenous people from the Maori sector, Indigenous people here in Australia, and for those of you who have worked in Europe, where you are working with local communities associated with the groups who are running the cultural sector. When you are using these technologies and trying to bring them to your projects, of course, you have had quite a bit of training behind that, whether it be through university or it's just been your own sort of time and effort with trial and error with these technologies. Do you feel that sometimes the use of these technologies can act as a bit of a barrier when you are trying to discuss and work with local communities who are trying to be involved with the project, but they just don't have the know-how and knowledge to understand what type of data that you do get from these technologies, and may feel a bit excluded in a way because of that?
I'd probably jump in and say maybe the opposite, in fact.
Yeah.
And I only say that because I feel like one of the brilliances of technology is that you can use it for multiple purposes, right? So we might be using it to ask archaeological questions or to find out about the landscape for the project that's being undertaken. But I think you can also use it as a really great communication tool. And so if we think about GIS, we were just talking about it, yes, it can be used for spatial analysis and it can be a really powerful analytical tool, but it's also great for displaying information, for sharing information, and for providing some access to what we're doing. And I think sometimes when you can show people what you're doing and how you're gathering it, there can actually be quite a good rapport that develops around the technology.
Definitely, there was a moment when last I was in Egypt before COVID hit, using the total station, doing some survey in a place in southern Egypt, and working with the local representatives from the Ministry of Antiquities. And it's just so interesting that these guys were involved. They don't have archaeological training, but when you do teach them about some aspects with what we are doing in terms of surveying, recording data in the field, and including them in all of that, they just feel so privileged and humbled to be able to learn that from somebody else. And that does create a bit of a good community sense within the project, because you want these guys to come on board, you want them to be involved in such a way, because by teaching them, it sort of has that knock-on effect that they have this experience to be able to teach others when they come through the field, especially for local people who do live in those countries and who have an interest in cultural heritage. I figure that is so useful, and it's a very good point. Anything else to add from this discussion so far? Sorry, Jessie, were you about to say something?
I was just going to say, oftentimes these sorts of training elements are built into the project too, or they're in terms of the work that we're doing with traditional owners in Australia, it's partnership research. So we're sort of asking them what they want as much as sort of suggesting what we think would be useful. And so a lot of the technology is not coming as a surprise to them. It's coming as part of that discussion and sort of setting up the project. So in that respect, we have a really interesting relationship built around the technology too. So I was just thinking there's one example where there's some elders who can't visit sites anymore because they are so elderly. But if you can record those sites and create models of those sites, for instance, that provides a different sort of access, but an access nonetheless. And again, as long as it's something that the community is interested in, I think we get that positive response.
There's a big community here as well. A Māori GIS conference has been organised over many years. And I mean, you know, I haven't been for a while, but I mean, the projects that are done are, you know, around the country here are just, you know, amazing. And I mean, you know, it's us keeping up with them often, not the other way around. You know, it's not. Yeah, I don't. Yeah, it's definitely a much more positive engagement in that regard. We're not teaching a lot of people anything that they can't you know go and get to grips with and actually push us to the limits on.
Yeah, support for from my perspective. That's falling into an open room with a door when it comes to Maori communities and using technology. But the other side of things, I think, you know, and that's quite universal. It's the technology is the one side of things, and it's getting the data, using the technology and analyzing the data. It's the one side, but I have the feeling in a lot, at least of the contracting projects, it comes down to the narrative. What does it actually mean? And I have now sort of started, we had in 99 a huge 3D project on Maunga Kia, which is one of the big pa sites, the big hill fort that we have in Auckland. But all the way since then, sort of for a lot of the contracting archaeological work, I find that getting someone in with a little bit of an artistic eye and actually creating a picture, a drawn picture with a view angle that sits in the landscape, and you have the archaeological site in the landscape, and someone just makes a nice drawing with people in it doing what people would have been doing on that site, essentially creating that narrative, a visual side of the narrative is as important. So in a way, the technology is there, and the data is sort of based around it, the analysis is based around it, but it comes down to the narrative. And the narrative doesn't necessarily need a lot of technology to be communicated.
That is such an important element, especially when I guess communicating research to mainstream audiences in particular, who may not know so much about the specifications. You put a whole bunch of data on the slide and people will go, wait, what is this? But if trying to find a way to communicate and connect with people, the narrative is definitely is so important, but I guess to be complemented by visual prowess, that's so important. Have you guys, what have been the challenges to sort of communicate your research to mainstream audiences despite all that technology that you have behind you? What challenges have you faced with trying to communicate that narrative from your projects to mainstream audiences in particular?
Time and cost.
Let's repeat that, sorry, Simon.
I mean, the big thing, just following on, you know, from the last thing, I mean, it's obviously local communities, you know, are part of it, but actually, you know, we've been doing a lot of sort of 3D models and various other sort of visualizations of the data. And one of the things is, of course, convincing your clients, who are coughing up quite large sums of money at times, that this is actually worthwhile. So, you know, there's a number of different stakeholders that we're communicating to all the time, and, you know, whatever tools we can, that's, you know, it's really important. And it's certainly, you know, one of my focuses has been on, you know, as well as, local communities, but it's also to our clients and going, this is how your data fits within a broader one. And that can be as simple as, like the radiocarbon dates, we put, I'll put in a chart showing all the radiocarbon dates from, the local region in comparison to the ones we've got for a particular project. Is a pretty standard visualization. And the message, most of the time, the message of that isn't that critical in terms of research, but it's really important to our clients to understand that they're contributing to this larger program of works, and we get very positive feedback on that.
There you go. Jesse and Kelsey, a question for you both, because coming from the academic space as well, especially with you guys having to try and communicate your research to people with non-specialist backgrounds in your field, what challenges have you faced from the academic point of view?
Do you want me to go first?
Sure.
Go for it, Kelsey.
I think, well, I guess, I don't know, maybe Jesse has the same experience. I feel sometimes when you are putting in for grants and you're sometimes thinking of a more method-based or technological approach, they sometimes shy away from that because there are other things that are more important to them. I guess this is some of my experience in the background with grant writing and having it more methodology, technology based. But I do think that they were going to start to see a change in that, or maybe we are, but I think that would be the most challenging. In terms of dissemination, I work with so many communities that I really enjoy being able to talk about what it is that we're doing and how we're working together and I don't find that challenging at all. Maybe because I started doing, when I was in undergrad, I would go to schools and talk to students about technology, try to promote women in science. And I think there's a way you can communicate to bring knowledge to the table where everyone can come to an understanding, because it's not very complicated, but if you make it complicated, it can be. So I think that's something I haven't had an issue with, but I do find with granting bodies, sometimes they seem to not want to fund a lot of technology-based projects and more projects that have, concrete research ideas, which I understand, but it would be nice to see, even with consulting, it is the money that's limited. And even with funding, we're not getting enough funding to enhance, other aspects of what our fields do. And technology could be one that could benefit from that. And I saw there's a comment in there about institutions or providing centers that do have, a bit more funding towards developing these skills and incorporating them. So I don't know. Yeah.
I can pretty much echo that. I mean, I think science communication is really what we're trying to do, isn't it? Where you focus on who your audience is, and you're always going to have multiple audiences. So you'll have, your peers and colleagues and everybody here today. You'll have the local communities, you'll have the general public, and these all require slightly different sort of narrative, like Hans said. And I guess I also noticed in the comments something about accessibility, which I think sort of picks up on Kelsey's comment about, well, what support is there available for these sorts of data storage or these sorts of centres or these training areas too. And so using technology, for instance, QGIS, which is freely available, these sorts of things can actually sometimes help. So if you start with those questions at the beginning of the project and think about the dissemination right from the get-go, then it's a little less complicated, or you run into fewer problems perhaps.
There is,
sorry, Hans.
Yeah, maybe just harking a little bit back to earlier in the discussion with indigenous communities. I think the geophysics, especially sort of cheap geomagnetics, because the moment you drag GPR and it gets just more expensive because of the time it takes to deal with the data. So geomag is quite good, and with the type of settlements that we have in pre-European, pre-contact New Zealand, geomagnetics are usually sort of a reasonably successful tool, apart from when you're standing on the side of a volcano, but we'll leave that out for the moment. But I think it's for the communities, it's quite important, because there is still sort of we don't touch those Wahitapu area. We leave them alone. So if there is a question, we can actually sort of show, okay, the oral traditions tell you about one thing and it should be here and should be there. And you can then actually go out and sort of check, okay, somewhere in that area, we know there is a kainga, it says in the oral traditions, you know, village, it's there, and you can actually go over the geomag and sort of saying, okay, where that motorway comes through, it is there or it is not there. Having the ability to do work that is not intrusive, that does not disturb any Wahitapu is often a really important aspect for the indigenous communities around here.
And just on that point in particular, Hans, technology is developing at such a rate, and of course, with archaeology in particular, it is a destructive process. And of course, when trying to investigate aspects of human cultural development, the occupation of certain areas, of course, excavation is always required. A question for all of you now. With the development of technology, do you think it will get to a state where it will potentially be able to determine where you can and can't dig to a certain degree, where you don't need to do excavation to be able to, I guess, find out where certain elements of human occupation has existed? Do you think excavation could be phased out because of the development of technology in the future?
That's a very good question. The only place I've ever seen where I thought, whoa, do we really need that, is the stuff that it's a Boltzmann Institute from Vienna, and they're doing, it's at Window Nissa, that Roman legion camp in the valley down there. And I've met a couple of times those guys from Ludwig Boltzmann Institute, I think. That's the proper name. And they utilize layers and layers and layers of non-intrusive technology to a point where they actually show you a fly through the drainage system under the street network of that Roman town. And there you sort of like get to the point of stuff like, whoa, do we really need to excavate that? But that's the only time that I personally had that feeling. I just, maybe there are other opinions out there. What do you guys think?
I would say, I think that, I mean, I don't think that technology will replace it 100%, but it just is another tool. And for Indigenous management of Australia, it works for a lot of people where they want to advocate preservation in place, or to show that there is the potential for something to be below that surface. So then they don't have to, they can manage it in a way by creating a boundary or something. And even if we get a negative result, because there's always been the stigma it doesn't work, it's still a result. Even if we don't find, you know, something that's cultural, you can still find information about the environment, the earth, whatever that might be. But I guess, you know, another thing, I was with the project, we were out doing a survey, and we were thinking that drones, though, would have been much easier for the pedestrian survey because of the vegetation. Like if you could fly, so some ways it could help manage. It'll never replace it, but you can find other alternatives. Instead of us walking an area and knowing that it's high vegetation, we're not going to see anything, take some drones out, save us some time, then we'll come back, do the slash and re-survey. So I just think it's everything we do is project by project basis. And it's what, you know, communities want, the stakeholders, what we can all do in a feasible time frame. But excavation, especially in heritage, if the place is going to have to be impacted, it's another tool that we can use to assist, but it probably won't replace it, the geophysical aspect or any of the spatial technologies ultimately. So, because there will be some things that will get destroyed. So then you think, well, how would you best want to record that data and that information? And technology would serve that purpose.
Indeed. Simon, Jesse, anything else to add to that?
agree with what Kelsey said. Essentially, it gives us a whole lot more information potentially, which we can use to make decisions around, like the example that you mentioned, Kelsey, where people might, if you know that there's something under there, it almost, in some context, doesn't matter what it is. It's just you can then decide not to investigate in that area. Or it might be, depending on the project, that you want to find where things are and you will then excavate. But it gives us much more information that we can use to make the right decision for that project.
Mm-hmm.
I think one of my favorite quotes is by the historian Harari. He sort of talks about machine learning in, you know, the transformation of machine learning, and he rated that there's a 97% chance the machine learning is not going to replace archaeology. So we're fairly safe on the, you know, the robots not taking over our jobs. I mean, I think what's really going to transform is what we excavate and the justifications for that. And, you know, the technology is really important. And, you know, do I think excavation is going to go away? Well, not unless, you know, there's radical changes in where people are living and, you know, putting roads through and all that. And of course, climate change. And, you know, standing back, you know, we're not going to hold back on that. And I think that's the massive challenge for that. So I think the key thing is what we excavate and when we excavate from these external things is going to affect much more than the technology that we have to do it. And the technology offers the chance to sort of transform, you know, something physical and in the ground into something that's, you know, meaningful and you know, to people as heritage, as a sort of created environment.
There you go. Thank you so much, guys. We're getting close to around 11 o'clock, and thank you so much for your answers and discussions, because this has been going for a good hour or so. To everybody that's on the chat right now, we're going to take a bit of a 10-minute break, and just to give you guys a bit of a rest, some water and a bit of food as well. And when we do come back, we'll have the Q&A session so that all of you guys, I can see, my goodness, there's so much stuff in the chat section at the moment. So I'm sure all of you have got a lot of questions to ask our panelists. Of course, that Q&A session will not be recorded to protect identities and other things like that. So this will be the end of the recorded section of the panel. So we thank you guys for jumping on board, and a round of applause to our panelists in particular. But of course, don't go away. We've got the Q&A session coming up very, very soon. So for now, guys, we'll have a 10-minute break, and we'll see you guys on the other side.